Okay. All right. Words. Give y'all your tests. Oh, yeah. That's who hasn't taken their test. That's right. Okay. We didn't do very good on the tests, except one of us. We need to study better, and we need to actually study, this class, and not whatever else. We're gonna start. I'm gonna take your questions on the test. It says also his work has less points on it. It's only 56 points on the test, so mistakes hurt worse. So that is part of it. Okay, let's start with this, because we didn't even study the basic vocabulary clearly. And so let's take a minute to at least hopefully learn some of the basic vocabulary. All right. Gavin, you're a silhouette. It's fine. You're a silhouette, which is not a problem. You can be a silhouette. you're just backlit. You're looking cool and spooky, which is totally fine. No, you're fine. It's not a problem at all. What are 1 and 2? What are those called? There's 2 possible answers. One that's better in context and one that's true, but less useful. So that is one of the things. They are adjacent. 1 and 2 are adjacent. So are 7 and 8. So are 3 and 5. Adjacent just means next to, right? All right, it's this one and that one. So yeah, 1 and 2 are adjacent. That's the one that's true. It's less useful because there's also something else that tells us something. What else are 1 and 2? They're a linear pair. Y'all may want to pull out your notes because I'm going to be asking questions and I'm going to be expecting you to answer them. And I'm not going to be expecting Mia to answer all of them, or Joe, or whatever else. I'm expecting you to lock in. All of you to lock in. All 5 of you, except one of you's a ghost and the other one is still not here. I thought he was going to be back today, but I don't know. Who knows? Maybe I got my wires crossed. 1 and 2 are a linear pair. Let's put that up here. If you can't find this part of your notes, take some new ones. Label it as, this is basic vocabulary that I need to know today. And I'm not kidding about those words. I'm not exaggerating. I didn't use the hyperbolic language and say this is words that we need to know yesterday. You got to take your test, buddy. Let me hand it to you, and let me give you a place to take it. I had it a second ago. Where did I put it? How you doing? You feeling better? Good. Once you cut, you can either, come with me. You can use a calculator. You have a calculator? You have a pencil? We can either pull you up a chair right here, or you can go in the back, or you can go right here in this room right here, whatever you want to do. If you do bad on it, don't stress. You won't be the only one. In fact, if you do good on it, you may be the only one. Okay. All right, where was I? Oh, this is a linear pair. Yeah, if you can't find this in your notes, if you don't know what this is, take some new notes. Label it better. Get you some tabs or something and organize your notes where you can find stuff. This is a linear pair. That's absolutely true. What was I saying? Oh yeah, this needs to be in your brain today. Like if I call your mommy up and say, hey, put me on the phone. And then I send a text over and say, what is this? Then you better be able to tell me this is a linear pair and how it's related. This you need to know today, before midnight. This is in your brain. Memorize it. I don't care. Do jumping jacks while you say words. I don't care. Whatever you do, this is in your brain today. Okay? Make sense? Good. It's a linear pair. How is a linear pair related? Okay, so that's how they look, which is, I think, what you're saying. Yeah, that's how it looks. It's on a line, but how are they related? How are they mathematically related? You can use your notes. You can even use a book. I don't care. There. Grab some information somewhere. How are they related? I'll take either the word or the mathematical thing for how they're related. Gavin, let me send you some pictures of your test so you can follow along better. What did you say? Measure of angle 1, right? Is that what you're trying to say, right? Well, it's 1 and 2 on this one, right? So the measure of angle 1. Yeah, absolutely. The measure of angle 1 plus the measure of angle 2. Where's my cell phone telephone? That's how I'm going to send pictures. There it is. All right, Gavin. This one, and then also this one, and this one. So just 3 pages, yes? Okay, great. All right, Gavin, I'm going to send this to you through Discord, okay? That way you can ask whatever questions you have and all of that stuff. Here in a minute, when I get done giving new notes. All right, it says it sent it. Hopefully you will get it. Okay, all right. Good. Okay, linear pair. They are related. They are related. Measure of angle 1. Everybody say this. How does we say that? Symbols. There's a lot of symbols. You need to know them. When you're introduced to a new symbol, oh, you need to understand what they are. That's like important information. Everything is important information. You got to learn a lot of stuff. This class is more vocabulary than any math class you've had in your life. More stuff that you need to just memorize than any math class you've ever had in your life, except maybe your multiplication tables. Right? There's a lot of stuff to remember. Which works out okay because the process is going to be real similar. Like these type of problems that you had on this test, you're going to have problems that are basically the same idea to the last unit in this class, where you've got a picture, things are related, you got to pull out an equation, solve the simple equation. We're going to have problems like that till the end, till May. Okay? So how do we say this? What does the M stand for? And what does this symbol stand for? Angle, and that's a 1. Hopefully you know that one. So measure of angle 1, right? Measure of angle 1 plus the measure of angle 2 equals 180 degrees. That's true. Linear pairs. Now, there's a word for that mathematical relationship. What's the word for that math relationship? Where are two angles add up to 180? What are they? They are supplementary. Remember, you can help to remember that by S for supplementary, which makes an 8. That's true. Linear pairs are supplementary. That's a linear pair. They're adjacent. Adjacent means just two angles right next to each other. 8 and 9 are adjacent. That's easy, right? We use there's no mathematical relationship for adjacent angles. That's why I drew this one. Like, these are not supplementary. They're not complementary either, right? We don't know what they are. We'd have to do some math and figure out what they are, right? So adjacent is true, and we use that as vocabulary, and you need to know what that means. But there's no math you can gain from it. But a linear pair, there's some math we can gain from it. Okay, so that's that. What about over here? What are 6 and 5? They are vertical angles. That's true. 6 and 5 are vertical angles. Vertical angles. What are 3 and 4? Still vertical angles. Vertical angles. How can we tell when they're vertical angles? They're like across from each other, right? The simplest way to describe it. They're across from each other. How are vertical angles related? They're what? No, they're not. What does complementary mean? Let's take your wrong answer as a learning point. What does that word mean? They add up to 90, right? So complementary angles, we'll go ahead and chuck that up here. Is that a 90-degree angle? No, it's not. How do I know it's not? Because it doesn't say it. It doesn't say it is. If it doesn't say it, it's not it. Unless it says it is. Now it's a 90-degree angle because I said so. If it's not labeled, if we don't do some math, if we don't do some stuff to prove it, we don't know it. But now it's a 90-degree angle. But so if I pop on another ray right here, and then I'll label me some angles, 13 and 14. 13 and 14 are complementary. You just said what complementary means, so let's say it again. What does complementary mean? Yeah, they add up to 90. These are complementary angles. So the measure of angle 13 plus the measure of angle 14 equals 90 degrees, right? Great. So back to vertical angles. How are they related? Angle 6 plus angle 5 equals what? I don't either. That's not how vertical angles are related. Go in your notes, go in your book. Find vertical angles. Popcorn. You graduated. Why are you trying to sell me popcorn? Don't forget that in the, except zero doesn't, don't forget that in the study guide portion, there's usually like a little glossary that gives you vocabulary words. That can be a way to find stuff quickly. It's also one of the first lessons, I suspect, but I could be lying. Did our thing actually go live? Let me see. Did I get an email saying it was? Oh, I did. Good. What do they look like they are? I know we're not supposed to do that, but let's use a little bit of like thinking to see if we can figure out what they are, since our notes are apparently terrible. We can't add them together and get anything. Like, who knows, right? Because the red ones are clearly, if we added them, it's going to be different than the blue ones, right? So it's not that, it's something else. What do you think they are? They have a mathematical relationship. What do they look like they are? Yeah, their measures are equal. How do we say that for pictures? Anybody remember? Numbers are equal. What are pictures? Now, similar is different. We won't get that. We don't get that till like Unit 5 or something. No, that's a decent guess, I suppose. No, they're congruent. They're congruent. What is the symbol for congruent? What lesson was due today? Just 2-1? Here's a piece of advice. There's going to be lots of those today, apparently, especially since we only did 2-1. If I say something in class and you're like, oh, I didn't know that before, write it down. Like, that's what we should have been doing, which is why the voice kind of rose at the end there to emphasize it. in the future, if I say something in class, because I know we've talked about it in class, ask what the symbol for congruence is. I've written it on the board. I've said things. Even if I'm like, we're going to learn more about this later, but I'm telling you this thing now, jot it down. Because here's the deal. People like to rag on lecture, which is sort of what I'm doing now, which is where you get up, where the professor or the teacher gets up here and presents stuff and says these are things here. But if you take notes, here's the deal with lecture. It hits all three learning styles. Every single one of them. It hits auditory because I'm saying words. It hits visual because I'm writing stuff on the board. And it hits kinesthetic because you wrote it down. And the bonus for that is now you have a little note that you can go back and be like, oh yeah, this is true. Does that make sense to everyone? Good. So, if I say something, write something that you didn't know before, jot it down. Take half a second to write it down. Okay? Good. Symbol for congruent is easy money. Because see, here's another cool benefit. Because sometimes in class I'll say something that's gonna come up later that you haven't watched in a video yet, and then you can be like, oh yeah, I knew that already when you watch the video, and then how smart will you feel? Congruent is equals with a little squiggle. And I said out loud, and I'm even gonna write it on the board so we can hit all the things. Numbers are equal. Pictures are congruent. Same size and shape. All of those things. Pictures are congruent. And that's the difference. When we get into writing proofs soon and very soon in the next couple weeks, one of the easiest steps is, okay, if our theorem said that the measures need to match, just change it to measures and say, because definition of congruent, segments, moving on with my life. Right? There are going to be some steps on proofs that you're like, this is so easy. Write it down and then you get some points. This is so easy. Yes, it is that simple. Okay. So, if we want to write that for like the these things, that color, the blue ones, mathematically, the measure of angle 3 equals the measure of angle 4. Or we could just say angle 3 is congruent to angle 4. This means that their angle is the same. This means that they are the same. Ding. They look the same. Their number's the same. Okay? Everything on the board currently. Oh, this was supposed to illustrate adjacent angles. If you want to like label adjacent angles, you can. But that was it. But I kind of talked it out loud. These are also adjacent angles, and there's also some adjacent angles over here. There's also some linear pairs over here. Where are there some linear pairs over here? 6 and 3 are a linear pair. How are they related? It's still on the board. How are they related? They're supplementary. They add up, their measures add up to 180. Absolutely true. Absolutely true. Everything that is on the board you need in your brain today, like today. Not tomorrow, not Thursday, today. These ones in here, today. It'll take 20 minutes max if they're not already in here today. Okay? Now that I've gotten the thing that I know we need to spend a little bit of time on, what questions do you have from the test? 7? Okay. All right, number 7, what we talked about today should help us get there, theoretically. I will remind everyone you can do corrections on the test. They need to be done on a separate piece of paper. You have to do all the ones you missed. They have to be complete and correct. They have to be completely correct. If you don't do something right, I will write fix on the top of the paper. I'll hand it back to you. I strongly recommend you fix the thing and then give it back again. And we keep doing that until you make 100. That gets averaged with your other one. So if you make a 50, your new grade on that test is a 75. If you make a 90, your new grade is a 95. Okay? If you make a 0, you can still at least get a 50, which I don't know how you could get a 0 on a test. Yeah. Just write your name and then you get a 0. And I get really frustrated and probably get like some dumb phone call from your parent because probably, I can say this has never happened, so this is a pure hypothetical, but probably your parent is a crappy parent. And so I'll probably have to hear from your stupid parent dealing with all of that stupidity. So nobody turn it in a blank sheet of paper, because then I will think probably your parent's dumb. So don't have bad things on your parent, especially if your parent is here. Okay, number 7, we got a figure, and it looks like this, more or less. And it is labeled 2z minus 16 degrees. And up here we've got an 8z minus 32 degrees. All right, we had some stuff on the board just a minute ago, some notes, some new notes, old notes. Oh, it's all the notes. One of those things that we wrote up there is useful to this problem. Which one? No, not vertical. That's why you said, oh, wait, no. Just turn the page to the things we just now wrote. You said what? Well, yeah. They're all measure angle things. What's the word you're looking for? What's the word that goes with this picture? No, not supplementary. Complementary. Supplementary is on a straight line. Supplementary is for a linear pair going all the way across. This is not supplementary, it's complementary. What does complementary mean? They add up to 90. So what would the equation be? Well, we just said it. Now stop. Don't even turn the notes. Lock in with the thinker. Right? What did we just say they do? Equal to what? They add up to what? 90. That's what we just said. They add up to 90. So, what are we going to do with those? Add them up, equal 90. So, this one, if you want to leave them in parentheses so you can like really, really see what's going on, you can. This one plus this one equals 90, right? Easy money. Now we've got a simple equation. Since there's just pluses on the outside of both of them, we don't need the parentheses, so the first thing we could do is drop the parentheses, right? We don't really even need those. We do got to combine like terms. Where are they? 8z and 2z. There's another set of like terms, right? Negative 32 and negative 16, absolutely. So what is 8z plus 2z? 10z. And then what's negative 32 plus negative 16? Negative 48. Now what? Add 48. Sounds like a good idea. What's 90 plus 48? 138. Divide by 10. So Z equals 13.8. I think that's what we're looking for, right? On solve for Z. Yes. You know what sucks more? That you didn't know that you should have done that. I'm not just being funny. I'm being a little bit funny, but I'm not just being funny. We talked about this a lot in Algebra 1. Those of you who were with me in Algebra 1, and those of you who are not, this is the first time maybe, but the point of having a test is so that you can figure out, okay, what did I not understand? What am I not doing right? How is my studying not quite working out the way I thought it should? What things can I figure out and tweak and change and improve? They're there for you to fix it and get better at it. It's never more true than in geometry. Because I've said this every class, and probably for at least a while we'll be saying it every single class, is that geometry is same over and over. Over and over and over and over and over again. Same stuff, new theorems. Okay? So if something didn't work in the way you studied, you can definitely fix it. And if you need help with that, you have a great resource in front of the room right now that can help you figure it out. Okay? On number 5. What? Do we what? No, you have to name 2 of each. Is what it says. Go ahead.
On number 6 would be equal to 90, right?
So angle 8 and angle 7, what are they? Are they complementary? Are they a linear pair? Are they vertical angles? They are adjacent, but that doesn't tell us anything mathematically, right? What else are they? They're a linear pair. How are a linear pair related? Yeah, the measure of the angles adds up to what? How many degrees in a straight line? 180. How many degrees in a right angle? 90. What's 90 twice? 180. Again, I'm being silly and not being silly. Really, 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 I cannot stress this enough. If you will like unlock your brain, you got this. You can do it. Don't just memorize. Think about why there's some vocabulary you got to memorize, right? But think about why the thing is true. Really, a lot of the theorems and definitely all of the axioms and postulates are all like pretty nearly common sense. I don't think you've seen this in the video yet. I think this will be in the next video. But I call postulates the no-duh statements. It's like, this is obviously true. You're going to get a theorem that says, it's actually not theorem, it's postulate, A, B, C, D, that says that BC is congruent to BC. No duh, that's obviously true, right? So that's you may, like, I'm making it kind of this big deal, like you got to memorize this stuff. And you do. You got to know the things. You got to know that that's called the reflexive property. But even then, that's not necessarily true, because here's the thing. When you get there and when you hit a proof, if you say what the theorem is and can't remember the name, that's 100% right. Okay? So, like, yes, that's a thing so what I'm trying to say is it doesn't have to be this giant thing. I mean, there's some stuff you're just going to have to flashcard it out. Yes, these are vertical angles, I remember, or the thing, because I memorized it, and that's what they're called. Like vocabulary stuff, yeah. You just got to learn new words. Shucky darns. You got to learn something in school. That's terrible. Right? But the theorems and the postulates, you can get there if you think for half a second. Right? So they add up to 180 is the short answer to your question. This one plus that one equals 180. Any other questions from the test? We can talk through at least the beginning of 4, at the very least, for sure. Yeah. We may let you finish the stuff, but we can at least start it at the very least. Oh yeah, 4 is the one. I forgot about 4. I do this every single year. I need to do this. This needs, I told y'all to do something today. If I have time, this is something I need to tell myself to do. 4 is impossible. 4 is a stupid problem because the answer you get doesn't make any sense. There we go. All right. It's a good thing you were virtual today. Good thing we had one more of those, because otherwise that just would have been black. No, it would have been useless to anybody that tried to watch it. We got a picture. We got a bunch of stuff happening on it. Let me give these points some names so that it's easier for us to talk about it today. Call this one A and B, and because we're going to be contrary, we'll call this one Q. That sounds fun. Okay, so we've got 3 line segments. What are the different line segments? What? AB is one of the line segments. What's another line segment? AQ is the big whole one. That's true. And BQ. Those are the different line segments that we have in this problem, right? Okay. So we've got 3 different line segments, and this is what I'm talking about. Where you got to figure out, you got to look at the picture, and you got to figure out, okay, how are these things related mathematically? How do they connect? So how do they connect? What's a theorem that we have that we can use to solve this problem?
AB plus BQ equals AQ.
Yeah. The 2 little ones add together to get the big one. Right? And so we just write that. We can even write it, we can do it in a couple of lines. The measure of AB plus the measure of BQ equals the measure of AQ. AB equals what? Yeah, 36x minus 24. What does BQ equal? X. So this plus x equals, what does AQ equal? 56x plus 18. And then you just solve that equation, you've got x equals some negative number, which is impossible, I know, but that's what's going to happen. And then you do it. Simple algebra, you got this. All right, let's talk about today's lesson for a couple of minutes. Well, you have to do all of the math anyway, so if you want to write one more line and write no solution, then that's fine, but it would technically be an extra step. Because you have to show all the stuff to negative whatever, and then, yeah, I would definitely recommend doing text corrections for most of you. Don't forget that the whole point of text corrections is to learn the stuff better. And so don't waste time just like copying stuff from Photomath. Like if you want to use Photomath or your cousin or whatever, great. Just don't just copy it. Like understand what it's doing. Make sense? Good. Lesson 2-1. What numbers did we do? 14 through 30 evens. Number 14. Each element in the pattern is 2 more than the previous element, and 10. Something like, you could use slightly different vocabulary, but basically that. How simple? Well, what did you wrote? I said each element in the pattern is 2 more than the previous element. That's what I said. Yeah, it's just not the same. Great. Number 16, each element in the pattern is 4 more than the previous element, and then 24. Number 18, each element is the square of the increasing natural numbers, 25. 20 is somewhere. Where is it? There it is. Each arrival time is 2 hours and 30 minutes prior to the previous arrival time, and 7:30 a.m. Number 22, something along the lines of each workout day is 2 days after the previous day, and then Saturday. 24 is the arrow pointing to the left. The direction of the arrow in the pattern rotates clockwise from one figure to the next. 26, each figure in the pattern is the next largest regular polygon, and it is a hexagon. It should be your picture. We went through 30, is that what you said? Okay. 28 is 2 miles. And 30 is yes. And she collected 105 cans. Don't forget that you can turn in stuff if you've missed and haven't, and you can still turn in late work. Make sure you get it done. Don't make me contact your mommy. I have done that a couple times this year. I don't like doing that. It irritates me, so don't make me do it. Okay, what other questions do we have?
What did you say the answer for 20 was?
The answer for 20 is something along the lines of each arrival time is 2 hours and 30 minutes prior to the previous arrival time, and then 7:30 a.m.
Okay.
Which one? 20. You probably just forgot how AM and PM work, but let's take a look at it. So the instructions are: write a conjecture that describes a pattern in each sequence, then use your conjecture to find the next item in the sequence. So the arrival times, 3 p.m. and 12:30 p.m. and then 10 a.m. What? We're reading them left to right, always. That's how English works. We didn't jump into Japan all of a sudden. Yeah. So yeah, that's true. I was gonna. You answered the first question I was asked. It was, is in this scenario, is time moving forwards or backwards? It's moving backwards, right? We're going back. How much each time? 2.5 hours. And then what's 2.5 hours before 10 a.m.? 7:30. 9, 8 and a half an hour.
Yeah, I wasn't even thinking.
You weren't even thinking?
I'm not even thinking about.
It's the wrong class for that. You got to think. You were looking at times and thinking, they've got to be going forward, and then your brain just melted for a second. But welcome back. Yeah. No, technically you didn't. What other questions do we have from this lesson? 24. What is your question about 24? Left is this way. What other questions do we have from this lesson? Well, there you go. Your next lesson is logic. You can do logic statements. It's a fairly easy lesson. You just got to turn things from saying if and then to have some symbols in it. Got to learn what the symbol for and or is, and you got to learn a little bit about truth tables. And then the next lesson is a little bit more convoluted because we've got some new vocabulary that you both heard and not heard using different context. We're switching statements around and learning some more logical things, foundation for a lot of logic stuff. And then in the next lesson, we're going to get into proofs. Sound good? What about it? Name the what? No, you can't name it Jimmy. You have to name it properly. How many points does it take to name a plane? No, it doesn't take 4. It takes at least 3. What about for a line? 2. And they have to be on the line. Like if it says the collinear one, you can't pick a random point that's off in space somewhere randomly elsewhere. It's got to be another point that's on that line. Which for the plane or the line? For plane, you'd have to say plane, bam, 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 3 points that are on that plane. Any 3 points that are on that plane, as long as they're not collinear. Because if you pick 3 points that are collinear, then that's an infinite number of planes spinning around that line. But if you pick 2 points this way and 1 over here, that's only 1 plane, right? Okay, kids, see you on Thursday. Go forth and think.